Okay, I've got a Mr. Cool universal 2-ton, 3-ton system split with the air handler inside. Now, this has been working for about 4 months, since May, and it's been working extremely well. Just fantastic. However, I discovered a design flaw in the system. I'm going to show you right now. I think that maybe there's a manufacturing mistake or something. But take a look at the amount of rust in less than 3 to 4 months. Look up here. Look at that rust. That is a lot of rust for just a few months. Way too much. You look at the coils, and the coils are solid. But it's the steel plates, galvanized steel plates. That's the way they should look. That's the way they are. Meaning they weren't galvanized, or when they poke the holes to run the copper lines, they break the galvanized plating. That rust is too much, way too much for 3 months. It should be spotless. So here's what I got to do. With Mr. Cool, there's no way to mount a corrosion grenade on the outside. It just doesn't fit anywhere, outside or here. It's impossible to fit. So I'm doing two things. I have a corrosion grenade from my old system, and I put it on here and just attached it to the steel plate. There's contact with the plate. I sanded down this old corrosion grenade to reuse it, so it's a solid, clean connection between the corrosion grenade and the steel plate. I checked the measurement, and it's pretty much 0 ohms. It's very little resistance between the plate and the corrosion grenade. I went a step further, and I got myself a magnesium rod. And I tied the wire around it, clamped it down. The rod's sitting in the channel, so any water, any moisture hits the rod, because you need moisture to make the anti-corrosion formula work. I used a copper wire, ran it to the corrosion grenade, so I'm calling this double anode technology. The magnesium is the strongest and should corrode the fastest, but I got the corrosion grenade as a backup, which is number 2. And this is all to prevent this rust. This rust is bad. I have a feeling those plates didn't even get plated with, these were not galvanized. That's crazy. They'll say sacrificial anode. No. You need something like a corrosion grenade or a magnesium rod to do that. This is my setup, and we'll see how it goes. I checked the continuity, and I pretty much have 0.1 ohms from the rod all the way through the corrosion grenade to the plate. The plate is not touching the aluminum, the corrosion grenade is not touching the aluminum fins, because I hear there's a reaction when that happens. So I just have it to protect, and this is now September, and let's see what happens in 6 months. I want to see that this stays the same and doesn't get any worse. There's a lot of solutions where you can spray chemicals, spray anti-corrosion, but how do you get in behind the fins? You just don't. It just doesn't happen. So I'm doing this, trying this out. We'll see if it works. Won't hear about me from about 6 months, because winter's coming around, and then I'm not going to get the moisture I need. But I'm hoping I'm going to get enough moisture here for the corrosion grenade and the magnesium rod. And I made sure the rod and the grenade were not touching any aluminum, because they say that creates a real problem. So that's what I had to do, and that's only 6 months, well, 4 months, May to now, to September. That's a lot of corrosion for that little period of time. And I was just coming up here to check things out. When I saw that, you can see how this plate is corroding. That's normal. That looks good to me. That's what it's supposed to do, but not here in the critical section. That's your critical section. And you can see it already spreading to the aluminum fins. And the aluminum fins are coated. Nice coating. And I even checked the continuity from out here to inside to the copper wire, and it's all working. So let's see what happens. See you in 6 months on this one.